A football player starts from rest 20 meters from the goal line and accelerates away from the goal line at 20 meters per second square. How far from the goal line is the player after 4 seconds? So we are going to find how far from the goal line is the player, and we are going to use this equation. And we are going to calculate this. So we can find 36 meters. A ball is thrown straightly upward with an initial velocity of 50 meters per second. What's the ball's acceleration just after it's thrown? How much time does it take for the ball to rise to its maximum height? What's the approximate maximum height reached by the ball? So the ball is thrown and maximum velocity is initial velocity is gonna be 50 meters per second, and the acceleration is gonna be 10 meters per second square. So firstly, we are going to find the acceleration. So this acceleration is gonna be the gravity. So 10 meters per second downward. And secondly, for solving this problem, we are going to use this equation. So we can find the time is going to be 1.5 seconds. And we are going to apply this equation for finding the maximum height. We can find this value, and we can also use this another way for finding the value. So the maximum height is going to be 11.225 meter. A projectile is launched from level ground with a velocity of 40 meters per second at an angle of 30 degrees from the ground. What will be the velocity component of the projectile's velocity just before it strikes the ground? So this is the projectile motion, and this is 30 degrees. So the initial velocity is going to be 40 meters per second. The velocity component of the projectile's velocity just before it strikes the ground is going to be this. Because this component is gonna be this. This is the force and this is y-axis. So we can find the velocity is gonna be 20 meters per second. Consider the velocity versus time graph, during which interval is the object at rest, during which interval is the speed of the object increasing. So firstly, A, B, and E, F are not the answer because these are not at rest but constant velocity. And second, since the graph shows velocity, minus velocity doesn't mean zero velocity, but velocity in opposite direction. So we can find the answer of the first question is going to be this line, the CD, and the answer of the second question is going to be DE, this part. A satellite of mass m orbits Earth at a height of h and a speed of v. What would the speed be for a satellite of mass 5m at a height h? So this is gonna be the Earth, and this is the satellite orbiting the Earth. So this is gonna be the height. And this is gonna be mass 5m. This is gonna be just mass m. So we can use these equations for finding the answer. And in this time, we are going to use this equation. So the mass of an orbiting body is not part of the orbital speed formula. The formula indicates the orbital speed formula. The formula indicates that orbital speed depends on the central mass m and the distance from it. This means that the masses m and 5m are the distractors and should be ignored. So the velocity is same. A satellite A satellite orbits Earth at height h with a period of t. If the satellite were to increase its orbital height to h, what would be its resulting period? So this is gonna be the Earth, and this is the satellite. And we are going to use this equation. So the period is going to be root 8r. So this is going to be the answer of this question. A satellite of mass m orbits Earth at a height of h and a speed of v. If the satellite were to drop down to an orbiter of 1 over 2h, what would be its resulting speed? So this is going to be the Earth, and this is the satellite, and this is the height. So we are going to use this equation, and this r is going to be 1 over 2r. So the velocity is going to be root 2 velocity. If the mass of Earth were to double suddenly, what would be the result of the velocities of all of the satellites in orbit around Earth? So mass is going to be doubled, and we are going to use this equation for finding the velocity of the orbit. So this is going to be double. So the velocity is going to be root 2 velocity. An object's velocity is measured each second and the data is summarized. What's the distance of the object? What's the acceleration of the object? If the object starts accelerating at 4 seconds, when its speed is 8 meters per second, what's the distance it will travel between 4 seconds and 7 seconds? So we are going to find the velocity, and the velocity is increased. We can find the acceleration is gonna be 2 meters per second square. And we are going to use this equation for finding the answer of the second question. So the distance of the object is going to be 16 meter. So this is the answer of the first question, and this is the answer of the second question. And the distance traveled at the constant speed between 4 seconds and 7 seconds is gonna be this. So the answer of the third question is gonna be 24 meter. A force of 40 Newton directed at 30 degrees from the horizontal x on a block of weight 50 Newton and proceed away across a level floor through a displacement of 10 meters. What's the work done on the work? What's the normal force between the floor and the block while the block is being pulled? We are going to apply this equation so we can find the work by multiplying force and distance and cosine 30 degree. So we can find the work done is going to be 350 joules. The normal force is equal to the difference between the weight of the block and the vertical component of the applied force. So the normal force is work minus this, and this is gonna be this 50 Newton minus 40 Newton. So the normal force is gonna be 30 Newton.